today's note, we are going to be looking at the distributive property. So this is kind of where we talked about the brackets coming into play. And I mentioned in the previous lesson on solving one and two step and multi-step equations that the b for the reverse bed mass or the opposite operation was lowercase because we do something a little different with that. So that's what I'm going to be looking at today. Before we get into that though, just doing a little bit of warm-up. If I told you that I have the expression 5b plus 2f plus 6s, and I wanted you to double this expression, what would you come up with? Now, if you were to think, okay, well, I want to double it, so how do I double it? Well, I got to multiply everything by 2. So we get 10b plus 4f plus 12s. What if I said then to triple what you just had? So if I wanted to triple what I just had, well, I've got to multiply everything by 3. So 30b plus 12f plus 36s. Now, how would I represent that mathematically, starting with my original one? And what I mean by that is if I had 5b plus 2f plus 6s, how would I represent doubling this expression? I know what it has to equal, but how would I represent that mathematically? And because we know that doubling means multiplying by 2, I'm going to put brackets around my entire expression and put a 2 in front. And that's telling me that I need to multiply this entire expression by 2. And mathematically what we're doing is we're taking the 2, multiplying it by the first term in our brackets, multiplying it by the second term, and then multiplying it by our third term. Same thing as if we're doing the second part. If we wanted to triple it, we're multiplying it by 3, and then everything that we're multiplying by 3 would go inside the bracket. 10b plus 4f plus 12s. And again, mathematically, the calculation we're doing is we're doing 3 times 10b plus 3 times 4f plus 3 times 12s. And that's an example of the distributive property. So the distributive property, or in other words, expand, is basically we're removing the brackets by multiplying each term inside that bracket by the multiplier in front. And we can see that by the arrows up at the top, right, in the example that we just did. To get rid of the brackets, I need to multiply everything inside the bracket by 2, or everything inside the bracket by 3. And then when we do that, we get our expression without the brackets. So let's work through a couple of examples. So we're going to expand and simplify. So expand, again, means to remove the brackets. Simplify means to collect any like terms. So if I want to expand this equation or expression, I need to multiply everything inside the bracket by the multiplier out front, which in this case is 2. So that 2 is going to multiply by the first term and multiply by the second term. So 2 times x is 2x plus 2 times 5, which is 10. I can't simplify anything else because there are no like terms, so this is an easy one and it's done. For b, I have negative 4 times, and then in brackets, x minus 2. So I want to expand by getting rid of the brackets. So in order to do that, I need to multiply everything inside the bracket by negative 4. Right? Keep in mind, look at the sign in front of the term to figure out the sign of the actual term. So in this case, it's a negative 4. So I need to be multiplying everything by negative 4. So negative 4 times x is negative 4x. And here, I'm going to say it's negative 4 times negative 2 to get positive 8. What you could do instead, we still have the negative 4x, And it could be, you could think of it, again, it depends on how you want to think of it. Do you want the minus there and to make it a positive 2? So you're subtracting positive 2. Well, then that minus needs to stay there. And then negative 4 times 2 is negative 8. So then we get negative 4x plus 8. So either way, it's still in the end. It's still the same answer. I would suggest just take the sign, whatever the sign is, in front of the number or term. Use that when you're multiplying or in any operation. So if that negative is taken up, then you're just going to either add or subtract whatever your number has, whatever the calculation works out to. Example C. So here I don't have any number in front, I just see a minus sign, but when we see that, we have to assume that there's an invisible 1. So we have to assume that there's an invisible 1. And I'll just so there's an invisible 1 in front here, so it's actually negative 1 that I have to multiply through. So I have to multiply negative 1 by x and negative 1 by positive 1. So here I get negative 1x, and negative 1 times positive 1 is negative 1. I can simplify, and I can just put negative x minus 1 if I want as well. I don't need to show the 1, because again, I'm assuming that it's the invisible 1. In D we have the same thing, except we have 2 sets of brackets now. That's not going to change anything. It just means that we may have some more work in the end. So I'm going to look, I have 2 times y minus 1 plus 3 times y plus 4. So the key thing here, the 2 in the first bracket is only going to multiply the things within the bracket it's attached to. So it's only going to multiply the y and the negative 1. It's not going to deal with the second bracket because it's not attached to it. The 3, on the other hand, will multiply into this second bracket. So when I go through, 2 times y is 2y, 2 times negative 1 is negative 2, and then plus 3 times y, which is 3y, and 3 times 4, which is 12. Now I can go through and collect my like terms. So I have my y's that are similar, and my numbers, or just constants. So 2y plus 3y is 5y, right? So remember, you're collecting like terms. And negative 2 plus 12 is positive 10. So in this example, here we have an example where we've expanded by multiplying to get rid of the brackets, and then we've simplified by collecting like terms. In example E, again, similar idea. Right? I look at my first bracket, there's nothing in front, so I can actually just drop these brackets. So 3a plus 8. In the second one, we only see the minus sign, but remember, that minus means there's an invisible 1 or a negative 1. So this negative 1 gets multiplied to everything in the second bracket. So the 3a plus 8 stays, and then negative 1 times 5a is negative 5a, so minus 5a, and then negative 1 times negative 1 is positive 1. I can collect my like terms by looking for my a's. Again, with the 5a, remember to include the negative in front. Include that sign in front of it. And then 8 and 1, just my constants. So 3 minus 5a is negative 2a, and then 8 plus 1 is positive 9. And I've simplified it as much as I can. F looks a little different. 4x plus 7 times negative 3. So this looks a little bit different than what we've looked at, but it's still the idea of distributing or distributive property, or multiplying or expanding, right? When we're multiplying numbers, it doesn't matter what order it's in, right? We can put like if I have, for example, 3 times 2, that equals 6. But if I do 2 times 3, that also equals 6. So again, order doesn't matter when you're multiplying, right? It doesn't matter which one's first and which one's second. So what we can do with this, if we want, is we can switch this to be negative 3 times 4x plus 7. So now it's something similar to what I've seen before. Or you could have left it and just understood that that negative 3 has to multiply with the one term and with the other. So either way you look at it, it's still going to be the same thing. It's just reversed. So negative 3 times 4x is negative 12x, and negative 3 times positive 7 is negative 21. And you would get the same answer on the other side if you did it backwards as well. Finally, with our last example, so here we're just changing up the terms inside the bracket, but the idea is still the same, right? In order to get rid of these brackets, I have to multiply everything inside the bracket by the multiplier outside of it. So 2 times 3a squared, and then the 2 times b. Here again, remember, I'm going to take everything, so the negative 5, so negative 5 times a squared, and negative 5 times 2b. Remember, the multiplier of 2 does not multiply anything in the second bracket because it's only attached to the first one. So 2 times 3a squared, I'm only going to multiply the numbers, or the constant and the coefficient. So 2 times 3 is 6. The a squared remains there. 2 times b, positive 2b. Negative 5 times a squared is minus, or negative 5a squared. And negative 5 times positive 2b is negative 10b. I can now collect my like terms, so I have the a squared terms and the b terms. Again, remember to take the sign in front, so these negatives here, it's a negative 5a squared and negative 10b. So when I combine my like terms, 6a squared minus 5a squared is 1a squared, and then 2b minus 10b is negative 8b. And if you wanted to, you could just write a squared minus 8b, and we assume that there's that 1 or invisible 1 in the front. So again, those are some examples of expanding and simplifying, or basically using what we call the distributive property. And the distributive property, again, is where basically the multiplier outside or in front of the bracket is multiplied by every term inside the bracket. And when you do that, you can drop the brackets. So that's how you get rid of the brackets when you're trying to solve equations.